Inheritance is a technique where I can define a relationship between two classes such that one class takes on or inherits the members of another class. So if class A has one method, one property, and one event, class B can also have that same one method, one property, and one event just by inheriting and not writing any additional code. But if class B wanted to have additional methods, properties, and events, it can. The syntax for inheritance is to use a colon after the name of your class, and then you specify your base class, the class whose members you want to inherit. You want those same methods and those same properties in your class. We've seen inheritance already when we defined a custom event arguments class for the gradebook's name changed event. All events in .NET should pass an arguments parameter that inherits from this base event args ultimately. I also showed you at the end of the last module how all exceptions in C# must derive from a base exception class ultimately. And what I mean by ultimately is you can only inherit from a single class in C#. That is, you can only specify a single base class after the colon. But the inheritance chain in C# is unlimited. That is, you can have class A inherit from class B, which inherits from class C, and in that case, class A is inheriting all the members from B and C. So in the case of event args and exceptions, I don't have to derive name-changed event args from that event args. I could derive from some other class that has derived from event args, but ultimately, event args is at the bottom of this inheritance chain. Just like in the second code snippet, class C is at the bottom of the inheritance chain of class A. It derives from B, but B derives from C. And with exceptions, you don't have to derive from system.exception. You can derive from something like system.arithmetic exception if your exception is math related, but ultimately that arithmetic exception itself is going to derive from that base core exception class. And that's quite common in inheritance hierarchies. You might have a class that has a base class that has a base class that has a base class, and somewhere down at the bottom of that chain, that base class forms some core abstraction that is used by lots of other code and lots of other classes in the system. But if you ever start writing that yourself, do that with caution, great caution, because it does tie up your classes and your code into a very tightly bound relationship. Let's take a look in our project. Picture this scenario. Things are going along well, we've written this gradebook, people are generally happy with it, but management does come along and say, there are some things we need to change. There are some teachers, not all teachers, just some of the teachers, they want a gradebook that will throw away a student's lowest score. So when the gradebook is computing an average grade and finding the lowest grade, it should throw away that lowest grade and compute the average grade and the letter grade without that lowest score. That gives students who might have had one bad day, one bad test, maybe they were feeling ill, that gives them a slightly better grade. And there's a couple ways that I could implement this. I could hit Control A, take all of the code that's inside of gradebook and copy it into a new class. Maybe I call it the throw away gradebook because it throws a score away. But that's usually the worst solution to any problem, to copy and paste code, because there are roughly 80 lines of code inside of this file, and I'm just duplicating that code and changing one little thing, which is the calculation. Another approach would be to just put a property on a gradebook, maybe a Boolean property. We could call it throw away lowest. And when someone wants to throw away the lowest score, they can construct the gradebook, set that property to true, and we could check it somewhere inside of our calculation. If throw away lowest, then we'll remove that lowest score and then calculate the average. That would be another way to do this. And really the best solution is going to depend on a very specific business context. So it's going to depend on how your team generally solves problems, and even more importantly, where your software tends to change. What is it that the business is trying to improve? Where do they keep asking for changes? A lot of times it's very difficult to anticipate where these changes are going to be, but pretty much any design problem that I have when I'm trying to evaluate one approach versus the other, it always comes down to that question of what's going to change in the future? Where do we need the flexibility? And the approach that I want to show you is not adding that Boolean property. The approach that I want to show you would be an inheritance approach. What I would do is create an entirely new gradebook class to throw away this lowest grade. So let's go to the project and add a class. Let's call it the throw away gradebook and click add. And this will be a public class. And it's not going to be a class where I copy and paste code into here from the other gradebook class. It's going to be a class where I inherit from the other gradebook class. So everything that that gradebook has, its properties like the name property, its methods like the add grade method, its events like the name changed event, this new gradebook inherits all of those. It's as if they were defined inside of this class. In fact, I could come back into my program right now and I could construct a new throwaway gradebook. But right now, let's leave off this constructor that takes a name. I could construct a new throwaway gradebook, assign that to a variable of type gradebook, and if I run the program, it's still going to behave like it did before. It prints out all the grades. I can enter a name for the gradebook. It computes an average. It computes a letter score. All of that is very good. We're not throwing away the lowest grade yet, but we are trying to reuse as much code as possible. Reuse code from the gradebook to take care of the events and so forth. So I don't have to worry about re-implementing add grade or anything else. There are some pieces that are not directly inherited, however, and those would be the constructors. If I want to name a gradebook immediately, when I constructed the previous version of the gradebook or the gradebook class, I could always pass in a string to the constructor, and that would populate that name property. If I tried to do that with the throwaway gradebook, the C# compiler is giving me an error because I do not have a constructor defined for this class that takes a string parameter. Even though gradebook has that, and it's still used in the construction of a throwaway gradebook, I'm not going to be able to construct an instance of a throwaway gradebook and pass a string parameter until I add a constructor here that takes that string parameter. And now the question is, what should I do with this value? Should I just assign it to the name property? And the answer is usually no. Remember, in the gradebook itself, we used to have some overloaded constructors. So we had another constructor that took no parameters, and it just provided a default value for the name parameter. And I was able to call other constructors inside of the gradebook using the this keyword. So I was able to say this constructor, what I really want it to do is call this other constructor inside of my same class. That's what this can do. You can pass control over to another constructor that's defined in the same class. What I need to do is pass control over to a specific constructor inside of gradebook, and I can do that not with this, but with base. That's saying, please call my base class constructor and pass in this name parameter, and we'll actually be able to see that we'll be calling the throwaway gradebook constructor. And I'm just going to copy that code and add that here to gradebook to see that we also call this constructor. The other piece that I'm going to do for right now is come down to where it's forcing us to enter a new name. And I'm just going to ignore that part for now. So Control K, Control C. By the way, one additional bit of information that I forgot to cover from the last module. When I declare a catch statement, here's an argument exception. If I'm not going to use this variable, which can hold the exception object that was thrown, I don't need to have it there. So I can just say catch an argument exception. I don't need to remember what it is. I'm not going to inspect the properties. And let's just console.writeLine invalid name. But now we have a program that's constructing a throwaway gradebook, assigning it to a variable of type gradebook, and then using that throwaway gradebook to add grades and compute statistics. And if I run the program, you can see the gradebook constructor is called, the throwaway constructor is called, we read in the grades, we compute an average, the program still runs as it did before. And the order in which the constructors are invoked is sort of interesting. You might think, since I say new throwaway gradebook, that we would be invoking that constructor, and this code here would execute first. But really, when you are in an inheritance hierarchy, the objects have to be built from the bottom up. So if I have this class that derives from some base class, we really have to construct that base class first, and its constructor runs, and then the derived type, or the type that is inheriting from that base class, its constructor gets to run. But knowing this, now let's try to tweak our algorithm so that we throw away the lowest grade. So right now, gradebook has a method called compute statistics. So I'm going to go into the throwaway gradebook and also give it a method called compute statistics. And again, the goal is to tweak what's going to happen inside of this method without trying to duplicate any code. Unfortunately, one of the things that I can do when someone calls compute statistics is I can always go to my base class. So again, there's that base keyword. And what I'm saying is I want to call compute statistics in my base class. So someone calls me, I'm going to turn around and call that method in the base class. Now, before I placed this method here, that's what was happening. Inside of the program, when someone said book.computeStatistics, that call would go to the gradebook compute statistics method because that's the method I'm inheriting. Now, in throwaway gradebook, I'm trying to provide my own implementation of this method so that it gets called instead of the method in the gradebook. But because I'm derived from gradebook, I can still get to that base class method by invoking it from here using that base keyword. So I'm going to say return base.computeStatistics. But before I do that, I'm going to remove the low score from this gradebook. So I could say that the lowest equals float.maxValue, and then we'll for each grade in the grades collection, but I don't seem to have access to grades, even with the underscore. And if I go into the gradebook class and check that grades field, it is private. And a private field is truly only accessible to the code that is inside of the same class. Something that is public is available to everyone. And what I really need is something in between. I don't want it to be completely hidden and only available inside of this base class because I want to use it from throwaway gradebook, but I also don't want it to be public and have just anyone access this value. Well, fortunately, there is an in-between setting, and that is protected. So this modifier says that grades is available to any of the code inside of this class, as well as any code that is in a derived class. And now what I should be able to do from throwaway gradebook is have access to grades. And I could say lowest equals math.min of the lowest grade that we've seen so far and the current grade. And once I have found the lowest, I should be able to say grades.remove that lowest value. Now, one thing I might need to be careful of in my program is that I am removing something from the grades. And if someone comes along and calls compute statistics again on the same gradebook object, we would remove another lowest grade and the student's score would keep improving. Ideally, and probably what I would want to do is make a copy of that grades collection, remove the lowest, run it through an algorithm, and then return the results. That way I'm never modifying the original collection of grades. But just to keep things a little bit simpler in this demonstration and focus on inheritance, I'm actually going to remove that from the record of authority of grades, that list of grades that is in the gradebook. Let's try to run the program. And if you might remember, what we had before was an average score of 80.8. Now that we have this new algorithm, we still have an average score of 80.8. That doesn't seem right. What went wrong? Well, let's try a little experiment here. Let's put a console.writeLine in and say that we are in the throwaway compute statistics method. And over here in the gradebook, I will find compute statistics and just put a little logging statement here to say that we are in the regular gradebook compute statistics. And now let's run the program again. And what I'll see is that gradebook compute is the method that was called. And that's because before we introduce some more topics in C#, that's because by default, when you're trying to figure out what method gets invoked, so over here in program.cs, when I see something like book.computeStatistics, by default, unless I do something special, the method that is going to be invoked by this line of code is going to be the method that is on or defined by the class that defines this variable type. In other words, because this variable book is defined as type gradebook, the methods I'm going to invoke through this variable are going to be the methods that are defined by the gradebook class, and not any methods that I have on the throwaway gradebook. If I take throwaway gradebook and actually define this variable as type throwaway gradebook and run the program, now we'll see that we do call throwaway compute, and throwaway compute calls into the base class, and we do in fact remove the lowest score, and the average score comes up to an 87.25. It doesn't improve the letter grade, but it does improve the average grade. So by default, the method that will be executed is chosen by the C# compiler at compile time, and it's chosen based on the type of the variable that you're invoking that method through. However, there is a way to change that behavior. That's what we'll look at next.